Welcome you all to the week 3 problem solving session of Basic Calculus 1. Myself Guru Bachan from Department of Mathematics, IIT Jodhpur. In this week, we do the problems that are based on one-sided limit, that is right hand limit and left hand limit, and limit at infinity and infinite limits. So we start with the left hand and right hand limit concept. So let me write one question, then we will discuss what is left hand limit and right hand limit and how can we find out it and how can we formalize it in specified definition, epsilon delta definition, you can say. So first question is, let y equal to fx graphed here. So we have given the graph of this y equal to fx. So there is a, you can say, hole here. So I'm drawing it like this, and then this graph is continued. There is again one hole, but here it is completed till is 2. This is 1, this is 2, this is minus 1, and this is 1. So here it is. So this is the given graph of y equal to fx. Now there are some limiting values of left hand limit and right hand limit that we have been told, and we have to find out which of the following statements are true and false. So which of the following statements are true and which are false. So these are the statements. First one is limit x tending to minus 1 plus fx is 1. Second one is limit x tending to 0 minus fx is 0. So you do first of all this a part, then we will discuss and then we will move to the other subparts. To start with it, so what we have to do here, we have to find out the left hand limit of this function f at minus 1. Oh sorry, right hand limit, not left hand limit. This is minus 1 plus. So can anybody confirm, is this given statement is true or false?
The first statement is correct, sir.
Statement is correct. Okay, how?
Because when we look at the graph, the minus 1 function's value is 1 at the y-axis.
First
Since
of all,
it is not asking minus 1 minus, so it is not needed, right?
what is the meaning of minus 1 plus?
Like it tends to be a little more than -1, but not perfectly -1.
Good. So let me discuss with others also. So here this limit x tending to -1 plus means that x near -1 with x greater than -1. So we are approaching -1 from the right side because the points only that are greater than -1 will lie here, here. So we are approaching like this from this side. So as we are approaching like this, how the graph is being approached from this path, and it will approach to this value, and this value is nothing but 1. So that means this statement is true. Any doubt? Now what about limit x tends to this 0 minus? The similar way we have to approach it. 0 minus. Where is 0 minus? What is the meaning of 0 minus? X is near 0, but x less than 0. Is this the meaning of 0 minus?
Yes, sir.
So that means we have to go to the 0 from this side, right? And how the graph will go then? Along this path? Where it will going?
Going near to 0.
Going near to 0. I hope no one is thinking about 1. So this statement is correct or false?
Correct, sir.
Next, limit x tending to 0 minus fx is equal to 1. This is a different statement, uh, different version of the previous statement. So this is talking about this 1. But as you see, as we are near this 0, the fx is approaching near 0. So will it be possible that a function have different limit at same point?
No, sir.
Why?
Because then it can't be a one or on to function. It can
Limit
be a function.
is unique. Okay.
Yes, sir.
To be precise, limit is unique always. So that means this statement is false. Now, what about limit x tends to 0 minus fx is equal to limit x tends to 0 plus fx? So first of all, what is the meaning of this 0 minus? 0 minus we have talked about. What is the meaning of 0 plus? That x is near 0 and x is greater than 0. And here it means x is near 0 and x less than 0. So that means from the one way we are approaching to 0 from the left hand side, and the another way we are approaching to 0 from the right hand side. So plus means always you can remember that we are approaching from the right side of at that point, and on real line it is so. So here we talked about left hand side. We know that limit x tends to 0 minus fx is nothing but 0 by v part. Okay. What about limit x tends to 0 plus of fx. So as we approaches to this 0 with this, then this function will be approaching to this. Correct? Correct? Any doubt? So
No, sir.
this will go to 0. So clearly this left hand limit is equal to the right hand limit. So combining them, what we can say? Limit x tends to 0 fx exists and equal to, is it correct? The statement is true. Now what about the e part? We have already did it. Limit x tends to 0 fx exist. Will it exist? Will it
No,
exist?
sir. At the f of x equal to 0, the function is not there, right?
Sorry.
F of 0.
We are talking about limit. We are not talking about continuity. We
Oh, okay,
have
sir.
not learned continuity yet. In week 3 lecture, we are not discussing continuity.
Okay, sir. Sorry.
Okay. So tell me, is this statement is true or false?
True,
Why?
because left hand limit and right hand limit is existing and it's unique.
So from the this D part, we can say that left hand limit equal to the right hand limit. So that means this limit will exist and this is equal to 0. Correct? Any doubt? If you are not getting it, please stop me in between and you can ask. This lecture is going to step by step in other direction. So it will be level will be going to be high. So at the starting, if you are getting the things, it will be a good. Otherwise, you will not able to follow up the whole lecture. So next is limit x tending to 0, fx is 0. Can I say that?
Yes, sir.
Why?
Because limit is unique and it is equal to 0.
How?
In previous cases, we have shown that x tending to 0 minus is equal to 0 and x
Good.
tending to 0 plus is also equal to 0.
Okay. So that means this statement is true. And by the uniqueness of limit, this must be false.
False.
What about limit x tends to 1, fx is 1, or limit x tends to 1, fx is 0? We are talking about fx tends to 1 is 1 or fx tends to 1 is 0. So to decide this limit, what we have to do? Recall, we have to calculate left hand limit, we have to calculate right hand limit, right? And then we will see whether they are equal. If they are equal, then what we can say? That limit exists. What we have to do? Limit x tends to 1, fx we need to calculate. Limit x tends to 1 plus fx we have to calculate. So limit x tends to 1, fx exists if and only if limit x tends to 1 minus fx is equal to limit x tends to 1 plus fx. Okay, so we need to approach one from the left hand side and the right hand side and see what is the functional or limiting value is going to be. So if you approach is to 1 from the left hand side like this, then where your function is going? Here?
1, approaching 1.
1. Good. When you are approaching this 1 from the right hand side, where your function is going?
The function is not defined, sir, in that side.
Who did say the function is not defined?
Sir, I said, sir, the function is not defined.
Where? At 1?
No, sir, at 1 right hand neighborhood.
I am saying this is the function 0.
Okay, then it's approaching 0, sir.
Yes. Then it approaches to 0.
Yes, sir.
So that means your left hand limit is 1 and right hand limit is 0. Are they equal?
No, sir.
So that means limit x tends to 0, fx is not equal to limit x tends to 1 plus fx. Therefore, limit x tending to 1 fx does not exist. So that means both the statements are false. Now the next part. I j limit x tends to 2 minus fx is 2. So that means we are approaching this 2 from the left hand side. 2 minus. Tell me, can we approach this 2 from the right hand side? Can we talk about this right hand side limit?
No, sir. If the graph is not there, we cannot talk.
We cannot talk about it. So we cannot talk about this one. Can we talk about this left hand limit of this minus 1?
No, sir.
The same reason.
Yes, sir.
So we are approaching this 2 from the left hand side. How the graph is approaching? Is it visible?
Yes, sir. Approaching to 0, sir.
Approaching to 0. So what we have given? Approaching to?
2.
So the statement is true or false?
False.
Because limit x tends to 2 minus fx is 0. Now in the same way, we have to discuss x tends to minus 1 minus fx does not exist. Minus 1 minus. I'm saying minus 1 minus. It's talking about this one. Can we say something?
Yes, sir. It does not exist.
It does not exist, or we
It
even
is
cannot
0.
talk about it.
We cannot talk about it.
So this statement is absurd. We cannot even talk about it. This statement is really wrong. We can't talk about it. Okay?
Sir, if it's like limit x tending to minus 1, fx does not exist, then what would be the answer? We cannot talk about it or it does not exist.
Sorry, can you repeat it?
Sir, limit x tending to minus 1, fx does not exist. What about this statement? We cannot talk about it, or we can say it to be true statement.
See, if you can approach -1 from the left hand side and from the right hand side, and the limit is coming out different, then we can say that limit does not exist. But when if you are not able to even move from the left side, then you cannot talk about it. For example,
Sir,
in this case, what happened? You calculate the left hand limit, you calculate the right hand limit, but both are not equal. So that is why we are saying limit does not exist. Yes, someone is asking something in between, please. Is it clear, Archit?
yes, sir.
Okay. So the last part related to this question is limit x tending to 2 plus fx is 0. So can we approach 2 plus?
No, sir.
No.
So correct. So let
Yes,
us
sir.
move to the next question. Let fx is under root 1 minus x square if 0 to x is less than 1, 1 if 1 to x less than 2, 2 if x is equal to 2. Now tell me what are the domain and range of f. First part. B part, at what points C does limit x tending to C fx exist. C part, at what points does only the left hand limit, can we write it LHL? Everything is fine, everybody is fine with that notation.
Yes, sir.
So LHL means left hand limit exist, and D part is at what point does only the RHL exist. So the easiest way to these kind of question is just draw the graph, and if the graph is possible easy to draw, just draw the graph. You can easily able to see from the graph what is the domain, range, what where the left hand limit or right hand limit will exist. So this is based on purely based on question number 1 and the previous lectures. So first of all you try at your own, then we will discuss it.
জাবজ কাকে গোটে খাপাট মারবে খাপাট মার জাবজ কাকে যেমন জামার জাতে না আমার उसने कोई भी चीज जाना भी माने खपटा ही तुम्हारे बारे
हेमा
चाहे कुछ भी काम नहीं जाना भी माने बंदर कर আমার
Sir,
yes Akshay.
sir, the domain and the range is from 0 to 2.
Okay,
And what does it mean by only exist in the left hand limit?
that means like the previous case, here you can see, you can talk about here only -1 plus. You cannot talk about -1 minus like that.
Oh, okay, sir.
Sometime it will exist, sometime it will not exist. Okay.
Okay, sir. For that function, it is 2.
Okay.
And the right hand limit, it is 0.
Okay.
Sir, the domain is from 0 to 2 close bracket, and sir, the range is from 0 to 1 close
So
bracket.
let us do step by
Union.
step. Wait. Let us do step by
Sir.
step. Let us draw first of all its graph. So what are the points? 0, 1, 2. This is 0, this is 1, this is 2. And under root 1 minus x square means it is a parabola. Okay. Which cut, which is, sorry, it is a circle. So how it will be drawn? At 0, this is 1. And at 1, this is 0.
0.
This
Open
approaches to
bracket.
0. So this will be a, there will be a hole. Okay. So let me.
Yes, sir.
So there is hole. Then from 1 to 2
Sir,
it is 1.
a straight line. Yes, sir, it will be 1.
This is a constant line from
Yes,
1
sir.
to this 2. Now what is x equal to 2? It is
2.
so we have to draw a little more here. So here it's somewhat 2. So this will be okay. Now
Yes, sir.
what will be the range or domain? It is
So domain will be to 0 to 2 close bracket.
domain of this f will be, see, the function is drawn started from the 0 and it is drawn till 2. So that means domain will be 0 to 2. What is the range of f?
Sir, 0 to 1 close bracket.
Okay. 0 to 1 close bracket.
Sir.
Are you sure it is a
No, sir, I am. Yes, sir. That is the first part only. 0 to 1 close brackets, union
no
2.
no. Anyone other? See, this is the range value that you are drawing. So you are saying it takes 0. At which point it taking 0? Tell me.
At the 0.
At
Oh,
the 0.
no, sir, no, sir, no, sir, no, sir. It will not take 0.
Wait, Archit. Akshay, what is the value of function at 0? Tell me.
0.
I am seeing it 1. Then why are you saying 0?
Oh, what? I said at 1, it is 0. Sorry, sir.
At 1 it is 0. Okay.
Yeah.
Where is 1? Here in the function. Here or
Oh,
here?
1 minus 1. Oh, okay, sir. Okay.
So is it attaining 0 at
No,
anywhere?
no, no, sir. No, sir.
So that means 0 will be open, and till what value it is taking. So till 0 to 1 you can say that it is taking every value, right? Right?
Yes, sir.
So 1 will be closed because
Close.
Close.
it is containing 1. Union. One more point is there, that is
1 to 2.
1 to 2. No, it is not taking any value between 1 to 2. It is directly from 1 it is jumping to 2.
2.
So range will be only union singleton 2. Only one value. Singleton means only one value in that set. Okay? Is it clear? Now what is the next question? At what points of C this limit extends to C exist? That means the left hand side limit, right hand side limit both are existing and equal. Am I right?
Yes, sir.
So there is a little graphical glitch. So this will start from here so that it will match like this. So that means left hand limit and right hand limit is working or equal. So as you can see there is a continuous curve here, right?
Yes, sir.
At any point if you will approach any point in between these from any C, I am saying any C between these, the
Yes,
graph
sir.
the graph will approach left hand side to the and right hand side to the same point, correct?
Yes, sir.
So that means in between 0 to 1 there is no problem, correct?
Yes, sir.
The same with go with between
1 to 2.
1 to 2, right? Now what about 2? We can only talk about left hand limit, we cannot talk about,
Right hand limit.
Right hand limit.
so that means we have to exclude 2, right?
Yes, sir.
So what is the conclusion? You cannot talk about 1, you cannot talk about 2, but other the all these points you can guarantee about it, right?
Sir.
Yes. Oh, in fact
With
on 0 also.
0 also.
0 also, correct? 0 also. So that means C can belongs to 0 to 1, any point, union 1 to,
2.
correct? Is it clear to everybody?
Sir, when we write, sir, 0 to 1, like, sir, the point right next to 0, how
Yes.
we will check the left hand neighborhood?
Suppose this is the point. So you can approach from the left and you can approach from the right, right?
Sir, sir, but it is very near to 0.
So it's fine now. We cannot talk about 0. You cannot go beside 0. But after 0, you can talk about any point. Give me any point. 0.00001. But still you can take any neighborhood. Smallest neighborhood you needed. You don't need the big neighborhood. You need smallest. That's why we are writing delta. That is, suppose 1 minus delta to 1 plus delta. That means very nearly we are roaming around. Very nearly to 1. We need just one neighborhood.
Yes, sir.
Okay. Now, what is the next part? Only LHL exists. LHL. See here. Can you approach 0 from the left hand side?
No.
No, sir.
Can you approach 2 from the left hand side?
Yes.
Yes.
So what is, where fx is approaching? 1 or 2?
1, 2, 1.
Uh,
1.
Approaching 1 now.
Approaching 1. Functional value is 2. Okay. So here C must be equal to 2, for which limit x tending to 2 minus of this fx is
1.
1. For simplicity, I am writing f of 2 is 2. This is not limit. This is only the functional value at 2. Okay. Now next part, last part, D part. For which value the right hand limit exists? Can we talk about the right hand limit of 2?
No.
No, sir.
Can we talk about right hand limit of 0?
Yes, sir.
Where it is approaching?
1.
1 or 0?
1.
1.
1.
1.
Because the function is present here. So that means c equal to 0, limit x tending to 0 plus fx is 1. And functional value of f of 0 is what? 0 or 1? Akshay, this time
1.
1. Good. Now no one has asked why we are not considering 1, because you have considered the case of this. You have considered 2, you have considered 0. Why you are not talking about 1?
Because it is asking only LHL or only
Only LHL
RHL.
or RHL exist. Now see, limit x tending to 1 minus fx is what? Tell me, when you approaches x from the left,
0.
0. Good. And limit x tending to 1 plus of fx,
1.
here 1.
1.
So that means both left hand and right hand limit of this existing, but we only asked either left hand limit exists, either left hand limit exists, or full limit, or you can say limit at that point exists. Okay, so this is not falling in any of the cases. That's why we have not considered it. Okay, clear to everybody?
Yes, sir.
Okay, now let us do some calculation for the limit, left hand limit and right hand limit. Calculate a part, limit theta tending to 3 plus, what this function is called? Floor function or ceiling function?
Ceiling function.
Ceiling function. Anyone other? Floor or ceiling? Is it greatest integer function or least integer function? Floor function. See, the best way to remember from the symbol. One symbol is like this and one symbol is like this. When you see your home, this is your ceiling and this is your floor. Okay, so this is a floor function, and floor function means least integer function. So first of all, what should you do? You should write the definition of this one. What is its value? Tell me, how the case divide?
X plus 1.
X plus 1. When x plus 1 it will be?
It's point something.
Tell me whether it will approaches to x plus 1 ever. See the definition of the ceiling function from the previous classes. See and tell me. This will never be x plus 1. As I told you, this is a floor function, least positive integer. So when x will lie in between n to n plus 1, this will be n. Now try this one on the basis of this definition. And what is the definition of that ceiling function, or you can say greatest integer function?
n+1.
So this is your floor function, this is your ceiling function. This is also known as, in the other words, it is known as greatest integer function. My statement was a little wrong. And this is your least integer function. So try this one. Can anybody tell me why it is called greatest integer function and why it is called least integer function? Anyone? Any guess at least? Archit?
Is it because it gives the biggest number which is not greater than the given number?
Somewhat near. Archit?
Sir, actually, like it's right, but I cannot guess it because greatest integer, the value is taking the least, and in the least, the value is taking the greater. I'm confused, sir.
That is why I asked, so that I can explain. See, greatest integer function means, have you read infimum and supremum? You remember it?
Yes, sir.
When we talk about supremum, we say that it is a least upper bound, and we talk about infimum, we say that it is the greatest lower bound, right? So it is somewhat similar to that. Greatest integer function means the integer that is less than the number, but it is greatest of all of them, all the other integers. For example, when you talk about 1.2, what is the greatest integer that is less than this 1.2? Tell me.
1.
And while if you talk about 1.2 ceiling function, that is a least integer function, that is that integer that is least out of the other numbers, and it is greater than this number. So what is that number?
2.
2.
Understood?
Yes, sir.
Now tell me the answer of this A part. You know the definition now? Limit theta tending to 3 plus theta divided by theta.
1.
1. Correct?
Yes, sir.
B part.
Sir, 2 by 3.
2 by 3.
So how we may write it? Theta value is 3 minus, means you are approaching, theta is lying between h is any positive number. So what will be the floor function definition will say? Tell me. What is the greatest integer function? 2, correct? And when you anybody is feeling difficulty in guessing this one? Anybody?
Sir, is it?
Yes?
Yeah. Okay, sir. Understood.
Understood? Archit?
Yes, sir. Understood.
So when you are approaching from the right hand side to this via floor function, then the numerator goes to 3 and denominator is going to 3. Then what will be the ratio? 1. In the same way, numerator is going to 2, denominator is going to 3. Then the ratio will be 2 by 3. So let us do one more question over this, but in some another form of infinite limits. So calculate limit x tending to tell me this one. Any answer?
Sir, in A part, we will got the limit infinite, or we can say does not exist.
Infinite. Infinite is fine.
Yes, sir.
Does not exist is not.
Sir. And sir, in second part, it will not exist. No, sir. It will exist, and sir, it will be equal to minus infinite.
Correct. How did you do that?
Sir, in the first case, so we directly know from the graph of 10x that
Exactly.
it will approach infinite.
It is not direct. You are approaching from the graph. Okay. So it is
Yes,
not the
sir.
direct. You are following the graph.
Sir.
So the best way to find out the left hand limit and right hand limit is, if you are able to draw the graph, then the best thing is to draw it first. So is it fine?
Yes, sir.
So this is your 0, pi by 2, pi minus pi by 2. Correct. So it's saying pi by 2 minus. That means you are approaching this pi by 2 from the left hand side. So that means you are approaching this pi by 2 from here. And where the graph is going?
Yes, sir.
Infinity. So that means limit x tending to pi by 2 minus 10x is nothing but
Infinity.
infinity. Algebraically, what we can write, since it is pi by 2 minus, I am telling you here. So what you have to substitute? You have to substitute x is equal to pi by 2 minus h, because it is talking about pi by 2 minus. Okay. So when x is approaching pi by 2 from the left hand side, then what will be the where will h go? Tell me.
0.
0. H will be pi by 2 minus x. Correct.
Yes, sir.
So x is any number near pi by 2 and less than pi by 2. So h will go to 0. So we can write h is going to 0, 10 pi by 2 minus h. What is 10 pi by 2 minus h?
What? H.
Again you have to go with the graph. In this particular scenario, you need the graph anyway. But in general, you can also do this left hand for the left hand limit concept. Like in this one, if you want to Achit, your voice is breaking. Is my connection is weak or yours?
Sir, his connection is weak.
Okay. So let's wait. So in this case, if you will write theta h tends to 0, this will be 3 plus h divided by 3 plus h. So what will be the value of this floor function of 3 plus h? By the definition, this should be greatest integer function now. 3 by
3 by
3
3
plus
plus
h.
3.
So it will be 3 by 3 equal to 1. So algebraically you also find out this one. Okay. But in this particular scenario, you definitely need a graph. So the next one is 1 plus cosec theta. What is the graph of cosec theta? Can anybody tell me?
The U shape on
U shape.
upper
What is the value of cosec theta at 0?
infinity.
Infinity.
Sir, it will vary. In the right hand side, it will be plus infinite. In left hand side, minus infinite.
Okay. Is it like this one?
Yes, sir.
And floor negative? Like this one?
Yes, sir.
So this will be your theta equal to
Pi.
pi. So now x is approaching from 0 minus, I am saying. So x is approaching from here. Where is going this functional limit of this function?
Minus infinite.
Minus infinite. So limit x tending to 0 minus of cosec theta is minus infinite. So from here, limit x tends to 0 minus, if I add 1 on both sides, does it make any effect? What is 1 minus infinity?
Minus infinity.
So we may write it, limit x tends to 0 minus 1 plus cosec theta will be.
Minus infinity.
So I'm only asking left hand limit rather than the limit existence. Okay. If you will approach this one from the right one, where the function limit is going on.
Positive infinity.
Okay. Is it clear to everybody? Can we move to the next one? Okay. Find the left hand limit and right hand limit at t equal to 0 of ft. Let me write ft here. Ft equal to 1 plus 1 divided by t to the power 3 by 5 plus 7. So you need to discuss the left hand and right hand limit of this particular function. You know both the approaches. You can even apply algebraically definition. You can draw its graph, or at least you can guess its graph. So here in this scenario, it's obviously too difficult to draw this graph, but you can guess at least from the power, or the best way to go with the algebraic one approach. So try this one.
Sir is not saying anything, or my network is going wrong.
He's not saying anything.
Okay, thank you.
Yeah, welcome. So have you got negative infinity and plus infinity as LHL and RHL?
Yes, yes.
Okay, thank you, bro.
Sorry, can you repeat yourself?
So, sir, I was asking, is the LHL negative infinity and RHL plus infinity?
Maybe Achit will confirm. I'll
Yes, sir. I also got that.
You agree with him?
Yes, sir.
Okay. Then let's do it. So limit x tending to 0 minus, sorry, here it is t. So what we will substitute in the function? 0 minus h. So it's obvious, if the limit will divide, the constant function will remain same and the limit will work on h tends to 0, 1 by minus h to the power 3 by 5. Since what is minus h cube?
Minus h cube.
And its fifth power, you can say fifth root, will be again negative because the odd number will not affect the sign, right? So it will be 1 by h 3 by 5 plus 7, and when h approaches to 0, this quantity approaches to infinity, but since it's with the negative sign, so it will be minus infinity. Is it correct?
Yes, sir.
So in the same way, when you try to calculate 0 plus f of t, limit h tends to 0, 1 by 0 plus h to the power 3 by 5 plus 7. Here it is a positive sign, so you don't need to take care even about the sign. It will be applicable to directly h to the power this 3 by 5 plus 7. Since our h is approaches to 0, then this quantity will approach to infinity, and addition of 7 does not make any effect. So left hand limit and right hand limit are minus infinity and infinity respectively, but can you say limit t tending to 0 ft exist?
What's that?
Limit t tending to 0 ft exist?
No.
So it does not exist. In short, we write DNE does not exist. Okay. So I hope.
So, can I ask one doubt?
Sorry. Yes.
If it was h raised to 4 by 5 instead of 3 by 5, then will it exist?
Then obviously it will exist. It will go to infinity.
Oh, okay, sir. Thank you.
That is the role of this even power and odd power. Okay. So next one is, let f be an even function, does, knowing that limit x tending to 2 minus fx is equal to 7, tell anything about either limit x tends to minus 2 minus fx or limit x tending to minus 2 plus of fx. Tell me, you know that left hand limit of this fx is 7.
So it will be still to minus 2 minus will be also 7.
Just a second, please. Yeah, please. Now.
Limit s tend to minus 2 minus f of x will also be 7. As
When
the
No,
it
sir.
is an even
No,
no
function.
sir.
no no
No,
no
sir.
no, that is
Sir,
see,
2 minus 2 plus will be 7, sir.
why?
Because, sir, x tending to uh, 2 minus we have given with 7. And it is an even function, then minus x will take same values as fx. So like the numbers less than to like 1.99999 is equals to 7. In the same way,
uh, your
minus
answer
1.999
intuitively
will be
is
7.
correct. Intuitively your answer is correct, but I want the proper mathematical approach that will be helpful from that algebraic one that I told you. Try to apply that algebraic one.
Yes, sir. We can write like limit x tending to minus 2 plus h minus 2 plus h f of minus 2 plus h.
Hmm.
Then we will take the minus sign common.
Hmm.
And as it is an even function, so it will be limit of sir minus 2 minus h.
So do I need to recall that what is an even function? F of minus x will be fx for all x in the domain of f, right? It is the definition of even function. So let's just go with minus 2 minus fx. So when you write it algebraically, so first of all let us see what is this 2 minus limit. So this is given you the 7 value. So limit h tends to 0, f of 2 minus h is 7. Correct? This is given.
Yes, sir.
Now go with x tends to minus 2 minus of fx. So this will be limit minus 2 minus h. Since it's an even function, so it will be limit h tends to 0 f of 2 plus h. but you know the value of f of 2 minus h, so we cannot talk about it. But if you consider minus 2 plus fx, so this will be limit h tends to 0 f of 2 minus 2 plus h, and when will you take the negative sign common? So this will be f of minus 2 minus h, and f of minus x is,
fx.
so this will be 2 minus h, and the value will be 7.
7.
Is it clear, Akshay, now?
Oh, sir. So in even function, if we take the negative sign of the function outside, then also it will become positive. No change will be there, right?
Yes.
Okay. Sir.
Is it clear to everybody? Okay. Till now we learned how to do the calculation, but what about the formal definition? That epsilon delta definition I can say. So for that, let given epsilon greater than 0, find an interval I 5 to 5 plus delta, where this delta greater than 0, such that x lies in I, then under root of x minus 5 is less than epsilon. What is, what limit is being verified, and what is its value? Understood the question? Here we are talking about 5 to 5 plus delta, that is x is near 5 but greater than 5. So that means you are talking about limit x tends to some c plus f of x is equal to L. When you will say this is equal to L, if and only if, recall the definition, corresponding to given epsilon greater than 0, there exists a delta greater than 0 such that x, tell me, anyone, such that for all x greater than x lies between c2 c plus delta, we have f of x minus L is less than epsilon. Is it correct? So that means you have not learnt about these definitions properly. I think this will be erased, so it's fine. Archit, Akshay,
Yes, sir.
You are not aware about these definitions?
Sir, I have
Not
not
sir.
seen the lecture, sir.
This is in the lectures. So let me tell you how this definition is guessing we are. So suppose this is your C point. Okay, this is your fx. So I am saying we start with this neighborhood. This is your value of L maybe. So you start with the neighborhood of this L minus epsilon to L plus epsilon. You are saying with respect to this neighborhood which right hand limit, which this interval you should take such that this lies between in this neighborhood. What is the meaning of this limit extends to C plus fx del is equal to L? You know very well from the calculation that you approaches to this C from the right and your fx approaches to this point, right? Is it the meaning of this one?
Yes.
So that means you are approaching C from the right. So here x lies between C to C plus delta. Correct? The neighborhood of C. Right neighborhood, I mean.
So sir, delta means a number less than closer to zero, right?
Closer to 0. Correct.
Okay.
Any smallest neighborhood of C. But from the right. We are talking about the right hand limit. If it was on the left hand limit, so it will be replaced by C minus delta to C. Am I right?
Okay, sir.
So fx must be lie between these intervals to limit to exist. Okay. So here what you have given? You have told that C value of C is here what? 5. Correct? Is it visible to you? 5 to 5 plus delta.
Yes, sir.
The question is saying na x belongs to this interval I, and I interval is 5 to 5 plus delta. So that means the value of C is nothing but
5.
5. Next, what we have given? X minus 5 is less than epsilon. So if this will imply where x minus 5 will lie between 0 to delta.
Yes, sir.
And this inequality what will imply? X minus 5 mod. When you remove under root, so it will be mod. This should be positive quantity. This will be less than,
Epsilon square.
okay. So that means if both things hold simultaneously, what you have to take? You have to take delta is equal to, is it visible to you?
Yes, sir.
Let me give you simplest one example, then we will move to this one. Okay, let us start with limit x tending to 1, x is 1. That you know it very well.
Yes.
Now let me first write the definition of limit x tends to C, fx is equal to L. This means corresponding to each epsilon greater than 0. What is its pictorial figure? If this is your fx, so that means whenever x lies between this neighborhood, your fx should lie between this neighborhood, right? This is the definition of limit now. If not,
Yes.
then please let me know. Then I can explain in a more thorough
Yes,
way.
sir. Yes.
Okay. So in the same way, here you are making epsilon neighborhood. So you are saying your fx must lie between in this interval, so that you are fixing delta in such a way. You are not approaching with delta to epsilon. You want to make sure your fx approaches to L whenever x approaches to C. Is it the meaning of the limit?
Yeah. So,
Okay.
sir, it means that when all the x tends to C, the f of s should be or
Should be
near
L.
to L.
We want to
Okay.
make sure fx should be L. So that is why we
Okay.
are starting with this epsilon neighborhood. We are talking about first of all the neighborhood of fx of this L. Sorry. When you are fix this L, then your delta can be manageable with respect to that, because ultimately what you want fx should be near L, correct?
Yes, sir.
So we start with that corresponding to each epsilon greater than 0, there exists a delta greater than 0 that you are asking about, Archit. We need only one delta, smallest neighborhood, delta greater than 0, such that for all x in this neighborhood, in this neighborhood, for all x with c minus delta to c plus delta, and x should not be equal to c. Remember now, deleted neighborhood. X cannot be equal to c while you are calculating the limit. We have fx minus L less than epsilon. Now, if any doubt in the definition, first of all let me know, then I can move forward. Any doubt? You don't need to worry, it will be a smallest one or a good one. Anyone? Okay. So as the definition says, we want to show that this should be less than epsilon. For that, we should calculate what is the delta. So here your fx is x
Equal to what?
and c is 1.
One.
And what is your limit? Guess. What is the guess of the limit?
One.
Okay. So that means you want that your fx minus 1 should be less than epsilon. You want this one, na? So what is the value of fx? X minus 1. You want this to be less than epsilon. This is your aim. And what you know that? You know that your x lies between c minus
C
delta
plus
to c
delta
plus
and C
delta.
minus delta.
So that means you know that x lies between 1 minus delta to 1 plus
1 plus
delta,
delta.
and x is not equal to, so if you
1.
will rewrite it, so it will be minus delta less than x minus 1 to plus delta. Is it correct? Is it correct?
Yes, sir.
So you
So
can
why
write,
it's not equal to 1?
recall, when you calculate the limit, you only talk about the left hand side, right
Oh,
hand
okay.
side, not
Oh, that.
exactly at c. Okay.
Okay.
So if you will write it, mod x is less than delta and it is greater than 0. Why? Because x not cannot be equal to 1. If x is not equal to 1, then mod will be a positive quantity. Okay. Is it clear?
Yes, sir.
So you know that your x minus 1 will less than delta, and here you want to show that this should be less than epsilon. So what you should take delta depending on epsilon, that it will be
Epsilon.
delta equal to
Epsilon.
epsilon. Then you can say that fx minus 1 is less than epsilon whenever this 0 less than x minus 1 is less than delta. And here delta is what? Where delta is equal to
Epsilon.
epsilon. But here you are talking about the whole neighborhood. And here we are only talking about the right hand neighborhood. Now you are able to see. This is your 0 x minus 5 less than delta. Sorry. And here you have given this is less than epsilon. So that means x minus 5 will be less than.
Epsilon square.
So here it is less than delta. So what you should choose delta equal to?
Epsilon square.
Epsilon square. So that means.
Sir, the epsilon equation, the root of x minus 5, that one will be given in the question, right?
Sorry.
The epsilon equation, like the epsilon should be less than, epsilon should be greater than root x minus 5 in the current problem. That
Yes.
one will be given in the question, right?
No, in this you have not given. You have to guess for which epsilon this is valid.
Okay, sir.
Here, this is a modification a little. They are giving you epsilon, they are giving you inequality. You have to guess. See, read the question. Just a second. You have to guess what limit is being verified and what is its value. You have to guess the limit L. You have to guess what is the value of C. Here they have
Oh,
asked the opposite thing. Okay. So
okay, sir.
from here, what you can tell? C equal to
5.
good. And from here, what you can tell? L equal to see, write like
Epsilon
this.
square.
Limit x tending to 5 plus. Tell me.
0.
0 of which value? X minus 5 is.
0.
If you will rewrite it, limit x tending to 5 plus x is
5.
clear.
Yes, sir.
Now give it a thought. Here is the solution. Then ask me.
Okay, sir.
See, there is a one glitch. We missed one thing. What is that? Recall that you want to show by definition fx minus L is less than epsilon. Is it so?
Yes.
So here what will be the fx? This is fx minus L. This quantity Are you able to relate it?
Sir, how it became fx minus L? Can you explain that?
Yes, please. See, I'm again writing the definition and you will let me know what is the definition of this right hand limit. Limit x tending to c plus fx is L. When it will be L? If corresponding to each epsilon greater than 0, there exists a delta greater than 0 such that for all x with where x should lie. What is the right hand limit?
C plus
C
C,
to c
P
plus
plus
delta.
delta.
For these values we must have what? Fx minus L
Epsilon
should be
less than epsilon.
correct. Now
Yes.
what you have given? You have given your x belongs to I, where I is 5 to 5 plus
5 plus
delta.
delta.
So that means x lies between 5 to 5
5
plus
plus delta.
delta, which can also be rewritten as x minus 5 to delta. Okay, so from here it is clear c is nothing but 5.
5.
Now other thing we know that x minus 5 is less than epsilon. So here what is which thing is less than epsilon?
F of x minus L.
So what is the value of f of x minus L then?
Root x minus 5.
So
Oh, okay,
it
sir.
should
Okay.
it should take the form of like this. So can I write root x minus 5 minus 0 whole mod? Is it
Yes.
make any difference?
No.
So you have given that this quantity is less than epsilon. So you know that your c is 5. You know that your function is this, right?
Yes.
So that means what is the question? Limit x should be approaches to 5 plus root x minus 5 is what is its value? Here is the limit
0.
fx, this is fx and this is your L.
L.
So this is the appropriate question. Okay, this is the
Okay, sir.
question. What is now what which value of for which value of delta this should be less than epsilon? Now you have to guess. This is less than epsilon.
Mm.
So that means x
For
minus
delta square. Delta square.
not delta square, epsilon square.
Epsilon square. Sorry.
So delta should be, now you got it.
Epsilon.
What is the
Yes, sir.
value of c? What is your function? What is your limit? Everything, right?
Yes, sir. Yes.
So next we will do a similar kind of question, but that is a discontinuous function, or you can say piecewise continuous function. So here let fx is equal to x square sine 1 by x, where x is negative, under root x when x is positive. So what you have to do, find a part limit x tends to 0 plus fx, b part limit x tends to 0 minus fx. These question will be answered by easily. Now Archit will say this answer easily. But next task is then use limit definitions to verify your findings. See, the algebraically, the graphical approach tells you the limit, but this will be verified by the definition of this epsilon delta definition that I told you in the above question. Okay, now C part, can anything be said about limit x tends to 0 fx? You first of all find out its right hand limit, left hand limit, and its limit at 0. Then I will let you know how to apply this limit definition. Okay, the 3 part belongs to yours, 1 part belongs to me. Okay, try this one. Any answer?
So the first one is 0.
Okay, and second one is,
Second one
Zero.
also 0.
what happened, Archit? You were silent at the
Zero.
time
Zero.
of that epsilon delta definition.
Yes, sir. I am not that much able to understand that.
But I was explaining the things, no? You may ask.
Yes, sir. I am trying to understand it.
Okay, so it's all very obvious. The both answers are 0, but as I said earlier, my focus will be how we can prove it. So in the first one, since it's a right hand limit, what will be the neighborhood? Tell me.
3 plus delta.
So
0,
0 plus delta.
0
and
plus delta.
what about the left hand neighborhood?
0 minus delta.
0 minus delta to 0.
Okay, so what we have to prove, fx minus 0 is less than epsilon. So
Yes,
you
sir.
start with, consider fx minus 0. Now since you are from moving from right hand side, so which will be your function, this one or this one?
So root x.
Root x. Good. So it will be root x minus 0. So this will be root x. Okay, now what you want, you want this should be less than epsilon. This is your target. Okay, I just wrote it just for your sake of simplicity, but you know that your x lies between 0 to,
0 plus delta.
so what delta here you should choose, or let me write it, 0 to x minus 0, or maybe x directly. So your x lies between 0 to delta. So what delta you should choose that root x is less than epsilon? It is very easy to guess. Tell me.
0.
Why 0? I am saying this should be less than epsilon. You know that x is less than delta.
Epsilon.
You want is this should be less than epsilon. X must be less than.
Epsilon square.
Epsilon square.
Good. If you will choose, so I am erasing it. Now our target has been achieved. So this is the way of writing this proof. So delta should be
Less than e square.
less than or maybe equal. Doesn't matter, because x is less than delta, no, ultimately.
Yes, sir. Yes, sir.
So x less than epsilon squared, then root x must be.
Less than epsilon.
So that means fx minus 0 is less than epsilon. From here you are telling it. Okay. Whenever, when it is happening, your x lies
Delta
between
equal to
0
epsilon
to
square.
0 plus delta.
Delta.
Where delta is what?
Epsilon square.
This is the way of writing it. Good? Understood now? Archit, any doubt?
Sir, I
Yes, please.
understand, but why we are taking delta equals to epsilon square? We can write it as delta less than equal to epsilon square.
Wait. You can write it. No worries. See, from the definition, what we want, for every epsilon, we need only one delta. It might be equal to epsilon square, it might be less than epsilon square. You are creating a great possibility. This is not wrong. You just need to prove for one delta. You are giving me
Sir.
infinite possibilities. That is also correct. That is not wrong.
Yes, sir.
Suppose I am saying you have a 0 to 1 interval. I will ask you what is the upper bound. Suppose you will say 1, and suppose Akshay say it will 2. So is Akshay is wrong?
No, sir.
So it is a giving great possibility, na? I am taking a precise possibility. Okay. Now let us discuss the left hand limit. What is the change in the left hand limit? Your function will be changed. From left hand side your function is,
X square sine of 1 upon x.
so consider fx minus 0. I am assuming that you know that how left hand or right hand limit is 0. So x square sine 1 by x minus 0. So this will be x square sine 1 by x mod. Can I write like this? X square is positive anyway. Now tell me, sine 1 by x is bounded with
Negative 1 to 1.
so upper bound will be
1.
1.
so x square into 1. I can write like this
X square.
and
Yes,
observe that
sir.
here I am not writing a light left hand side. Okay, left hand side I am not writing, and this symbol will change according to the previous inequality. Here this is x square sine 1 by x, and you know that sine 1 by x mod is less than equal to 1. Therefore you wrote here less than equal to. Okay, and
Yes, sir.
if I multiply with them there will be equal, because I am telling the relation between the previous line and the forward line. If you will write, for example, fx minus 0 fully, then you will write x square, because it is equal, equal, then less than equal, then equal. When you talk combine them, what will be the relation?
Less than equal.
Okay, this is the method to write. Understood?
Yeah.
Now what you want, this should be,
Less than epsilon.
now what you know that 0 minus delta x lies from
0 plus.
right.
Yes.
Now what should you do? Tell me.
Mm.
What delta should you choose?
Delta square and
Your guess is right. But epsilon square. You mean to say epsilon square. See, it is greater than minus delta and less than 0. So if you square both the side, well, what will you get? Is the relation will be reversed? Will you agree or not?
yes, sir.
Archit,
Yes, sir.
because negative if you are taking, suppose minus 2 is less than minus 1, when will you square? This will be reversed. Correct?
Yes, sir.
So that means your x square is less than delta square. Now what you choose? You want this to be less than epsilon. You should delta square to be, right?
Yes.
Or if I say in the language of Archit, this should be less than.
Epsilon.
So from any of them, what you can say? Mod
Sir,
of,
but how we can say that it is less than epsilon when both the x square in the above condition and the below condition are same?
what you want? No, this we want to show. We don't know about it.
Oh, okay.
We want to show it. So let me write it with a different color. So this we want to show it. That is why I made it red. Okay. This we don't know. We want to show it. We want to prove the limit, na?
Oh,
So this should be less than epsilon whenever your 0 minus delta less than x less than 0, where what is delta? What is delta?
root of epsilon.
Is it correct? Clear now? So C part. What will be the limit of fx? Will it exist?
Yes, sir.
And limit extends to 0 of fx is
0.
understood? Now The next question is use.
Sir, can I ask one question?
Yes.
Sir, in the LHL and RHL, aren't we find out by squeeze theorem?
Yes. In squeeze theorem.
So, so it's already saying that limit s tends to f of x is this. So, do we need to prove it again?
You have to think about the domain. Your function here is defined for x less than 0 and x greater than 0 separately. There are two different functions. So definitely
Oh,
you need to do separately. Okay.
okay, sir.
Let me be precise my word. You have to do. You need not to. You have to do separately. Okay. So we have to use the formal definition to prove that minus 2. Now tell me what is the limit of this function? What is the limit of this function? Anyone? Archit, Akshay?
It does not exist.
I mean, obviously it does not exist, but in terms of infinity, I'm
Sir,
asking. Is it plus infinity or
sir,
minus
Negative
infinity?
infinity.
sir, plus
Negative
infinity.
infinity.
Negative infinity, Archit. Here is negative sign.
Yes, sir.
So, in the above,
Sir, one more question.
yes, please.
Sir, is the negative infinity square can be written as infinity square?
Yeah, I mean, negative will be removed, na?
Oh, okay.
So, what I'm saying, yeah. Earlier, what you were doing, you were talking about this is equal to L, but here this is not L. What is this? This is infinity. So how we write it? We don't write here epsilon. Suppose how I can say a number is greater than a number is infinity. How I can say that a number is infinity?
Sir, if it
Suppose
is greater
hmm,
than any given number,
it is greater than any given number. Then only I can say that it is greater than infinity. Now, in the same way, we write this definition also. So, corresponding to each m greater than 0. Every m, if you take suppose m equal to 10, then I can say there will be a what will be for m equal to 11, m equal to 13. So if any number is infinity, then it will be greater than to any number, any real number. Correct? If a number is going to infinity, then obviously it is greater than 1000, 2000, 10,000. Is it? It sounds correct?
Yes, sir.
So I am saying corresponding to each m greater than 0, there exists a delta greater than 0 such that there will be a neighborhood, deleted neighborhood, such that for all x with c minus delta less than x c plus delta comma x not equal to c, we have fx must be greater than m. If
Sir,
you,
why we put the condition m should be greater than 0?
because we want it to be infinity. If there is a positive number, then you can say that it is going to infinity. Suppose there is was minus infinity, then what how we write? We say that there exists a positive number and fx should be less than -m. This is the way of writing. Suppose m is a positive and you are writing like this. So that means if you take m to be 11, this will be minus 11, and I am saying this holds for every m. So that means minus 11, minus 1000, minus 2000. Fx should be less than that. So that means fx must be what? Minus infinity or infinity?
Minus infinity.
Minus
Minus
infinity.
infinity.
So this is the way of writing this one. So we want to show that this fx should be greater than m. Okay. So you want this to be shown. So what is your fx? Minus 2 by x minus 3 whole square.
Whole square.
Minus 2 by x minus 3 whole square. You want this to be, let me write in red one so that it will be clear. Your target is this to be greater than,
M.
so that means x minus 3 whole square. Solve it and tell me. 2 by this one is less than minus m. Is it correct?
Yes.
So that means x minus 3 whole square divided by 2 is greater than
Negative 1.
minus 1 by m. I reciprocated.
During reciprocation also we change that sign, right?
Yes.
Oh.
Suppose 1 by 2 is less than 1. Reciprocal it.
Yeah, 2. Okay.
Okay. But the number should be positive.
Yeah,
Only
okay.
in that case you can do that. Okay. There is one mistake we did it.
But it is negative infinity, right?
This is negative infinity. We did the mistake. So this should be less than minus m. Okay. So this should be, we want to show it to be less than minus m. Okay. So then this will be greater than m, and now this will be less than 1 by m. Is it fine? Is it fine now?
Yeah, yes, sir.
So x minus 3 whole square will be less than 2 by m. Okay. So from here what can you say that mod of x minus 3 should be less than under root, correct?
2 by M. Yes.
Now recall what you know that about the neighborhood of 3. X tends to 3. That means x lies between 3 minus delta to 3 plus
3 plus
delta and
delta.
x not equal to 3. So you know that your 3 minus delta less than x, 3 plus delta with x not equal to 3. So if you will combine it, it will be mod of x minus 3 is less than delta and greater than 0. So from here what you should choose your delta, so
So
that
how 0? Okay, okay. Mod. Okay.
mod and this x not equal to 3, so it will
Okay.
imply this should be strictly greater than 0.
Okay.
So now what your delta should be chosen?
It's root of 2 by M.
Good. Now what is the way of writing it? You start with this part is your rough calculation. Okay. Okay. You know that you chosen delta to be under root 2 by m. So you are saying if this is less than under root 2 by m, then your mod x minus 3 is less than under root 2 by m, and if you will solve it, what you will get? X minus 3 whole square is less than 2 by m. Is it correct? We will do the reverse calculation now to show that fx is less than minus m. Now solve it, get to the function value. Now tell me, Tell me how we can make the function. What is our function? Our function is minus 2 by x minus 3 whole square. We have to reach this one. So if you will reciprocate it, it will be
The sign change m by 2.
Greater than m by 2, yes.
so this will be
The 2 will cross.
and
Then
minus.
again sign change.
So you got your fx to be less than
Minus m.
Minus m.
whenever your x lies between but x not equal to 3 and where your
3.
delta is
Root 2 by m.
or maybe less than root 2 by m as you said.
So, sir, first we have to assume it is less than minus m. Then we have to make a round and
We are not
come to
making
that.
assume. We want to show that.
Oh,
We
okay.
seek to show that. That is why we assume. Okay. You should
Okay,
be
sir.
precise with your words. Okay.
Okay, okay.
So the last one is your homework. Is this similar the other one? We may discuss if you will not get it. Use formal definition to show that limit x tending to 1 minus 1 by 1 minus x square is infinity. Okay. If you will not know the definition of this, you may refer to the lectures of week 3. Then we may discuss in the next class. Okay. Any other doubt?
No, sir. The next class also on Monday or
Tuesday. Mine class is on Tuesday, and the
oh,
another problem solving session is also going on Monday 6 to 8 or maybe 7 to 9, that I don't know exact the timing. You may check it. But there were 2 days problem solving session is going on. One is on Monday and one is on Tuesday. I take only on Tuesday. Okay.
okay.
The another
Sir,
problem. Yes, please.
sir, where we can get the PDF of these solving sessions, problem solving session?
We have shared. We are uploading regularly.
Where, sir? On the site.
um, we have given a link where we have uploading the video links also and this PDFs also. You may consult in the group or maybe with the team, technical
Sir,
team.
sir.
Okay.
Yes, sir.
Any other query?
No, sir.
Okay.
Thank you, sir.
Welcome.